Okay, our next topic is differentiate e raised to the power ax, sin ax and cos ax. In chapter 10, you will learn about the radians. Radians are just an alternative way of measuring angles. The conversion between radians and degrees is basically pi radians is equals to 180 degrees. If you have to find the value of 1 radian, 1, that will equals to 180 divided by pi. How? Because this pi goes on the right side and divided by 180, so it will becomes 1 radian is equals to 180 over pi degrees. And if you are finding the value of 1 degree, so this 180 goes on the left side and divide by pi radian, so it will becomes pi over 180, that will be equals to 1 degrees. Okay, these rules apply when radians are used. Now the key point is that if you have y is equals to sine ax, this is your function type in which the inside of the sine is basically the multiple of x, so its derivative will be, what is the
Teacher, your
derivative?
voice is lagging. I can't hear you.
Okay, just wait a minute. I am just telling you that if you have the function y is equals to sine ax, now my voice is clear or not?
Yes.
Okay, if you have the function y is equals to sine ax, you can see that what is the derivative of sine ax? That is simple cos ax, right? Do you understand?
Yes.
And now the variable used as ax. So what is the derivative of ax? That is simple a. So that's why this a is multiplied. Any problem in this step?
No.
Again, if you have the function a times cos, this is the mistake. uh, this a is in the cos. Okay, this is the mistake, you have to correct this. If you have the function that y is equals to cos ax, so what is the derivative of cos ax? That will becomes minus sin ax, right? Any problem?
No.
Okay, and what variable is used into cos ax? That is simple ax. So what is the derivative of ax? That is simple a. So this a is multiplied. So this is the method. You can also write the key points using the chain rule and prove these key points. Understand?
Yes.
We use simple method to find the derivative, and you can also use simple method as well as the chain rule. You will also need, when your practice will becomes very high, it means you can understand that the simple method and the chain rule method are also same, but the interpretation is different. You will also need to differentiate the exponential function you met in chapter 1. The function e raised to the power x is very special, as the gradient of the curve is the same as the value of the function itself. If you have y is equals to e raised to the power x, its derivative will also equals to e raised to the power x. Okay, this is the exponential function. If you have e raised to the power ax, so if you take the derivative, e raised to the power ax is as it is, and also what variable is used? That is ax. So what is the derivative of ax? That is a. So a is also multiplied by this one. Here is the mistake, we have not any a, so you can write a e raised to the power ax. Do you understand?
Teacher, why would there be a A?
Because in previous method, when I have explained you that e raised to the power 3x, when we take the derivative of e raised to the power 3x, e raised to the power 3x has the derivative e raised to the power 3x, and now which variable is used? That is simple 3x. So what is the derivative of simple 3x? That is 3. Now in this case we have not any 3, we have a constant, any constant, that is a. So e raised to the power ax has the derivative e raised to the power ax and multiply by simple a due to the variable is ax. You can also use the chain rule to prove. How? By using chain rule, let y is equals to e raised to the power ax and let u is equals to e raised to the power, sorry, u is equals to ax, right? Now what is the derivative of du by dx? Du by dx, that will be equals simple a. Any problem?
No.
Okay, if you put the value of u into this value, so it will becomes y is equals to e raised to the power u. So what is the derivative? Because you have learned that e raised to the power x is that function which derivative, it has the derivative also same. If you write it as dy by du, that is equals to e raised to the power u as well. Understand?
Yes.
And when you take when you just put the values into chain rule, dy by dx is equals to dy by du multiply by du by dx. So it will becomes, what is dy by du? That is e raised to the power u. And what is du by dx? That is simple a. So what is the value of u? That is ax. So we can write it as e raised to the power ax dot a. So we have proved this key point note 2 by using simple method as well as the chain rule. Now you can understand.
Yes.
And also you can prove this one, right? How you can prove? Can I prove it by using chain rule?
Yes.
So first of all, you have y is equals to sin ax. So let u is equals to ax and the derivative will becomes, I just write the derivative simple a. Okay. And also you, when you put the value of u, it will become sin u, and sin u has the derivative, that is simple cos u. Any problem?
No.
So if you find the derivative dy by dx, that will be equals to dy by du, that is cos u, multiply by du by dx, that is simple a, right? And what is value of u? A is as it is, the value of u is basically ax. So a times a cos x, cos ax. So this is your answer. Understand or not?
Yes.
Now you can understand the key points which we are using in this topic.
Yes.
Okay, good. Now we have to do the example.